Hello guys, today we are going to see the project demonstration of an IoT based street light monitoring system with fault detection. So the main concept of this project is we are going to monitor the street light which is capable of entirely self-operatable. Self-operatable means the power source is of the street light will be solar. From the solar energy, from the PV panel, the solar energy will be converted into the electrical energy. Then the electrical energy will be stored in the lithium-ion battery using BMS. Then the generated power supply will be taken to the street lights. So the street lights is fully automatic using LDR and obstacle sensor. We are going to detect whether it's a day or night. The LDR sensor will take the responsibility to detect the intensity of the light, and based upon the light intensity, we are going to predict whether it's a day or night. And obstacle sensor will actually we use IR sensor for obstacle detection. So obstacle detection is nothing but whether if any people are walking in the street, it will detect. So people are there, so we need to turn on the street light. So the continuously if you are turning on the street light without any people, it's waste of energy. So here what we are going to do is we are going to set an array of street lights, and few arrays will be turned off if no person is walking in the street, and one array of light will always glow. It depends on the LDR. So like this, the entire setup has been made. If any fault occurred in these street lights, the GSM modem will automatically send a SMS to the particular in charge person that the street light is a fault, like that. So this is the block diagram of the project. So the block diagram starts with the microcontroller. We use Arduino microcontroller here, and the LCD display is here, and the entire circuit was connected with the IoT. So IoT here IoT will be the important part. So we can through the IoT part we can easily track whenever the street light get fault or what are the voltage variations, and whenever the light is turning on and turning off, everything will be recorded in the IoT. So which is very helpful to track. And the LDR sensor, light dependent resistor, so it will tell you the light intensity. Based on that we can predict whether it's a day or night. And IR sensor will act as a obstacle sensor, and a GSM modem to send SMS, and a voltage sensor will check how much of is there any fault in that street light, like that. So the street light connections controlled by a driver, and this is the battery with the solar panel and charging circuit. So this is how the entire circuit has been made, and there is a software part. So this is the abstract of the project. So which includes literature survey, hardware descriptions, etc, etc. So guys, let us see the live demonstration. So guys, as I shown in the block diagram, so this is the complete hardware setup. This is a prototype, so I use the minimum hardwares so for cost cut of everything. So the first step is I'm connecting the internet to our IoT device, because it's an IoT platform, so without internet the entire process will not work. So first I'm giving the internet by turning on the hotspot. So after that I'll explain you what are the hardwares I'm utilized here. So the main microcontroller, which is ESP8266 module I used. So all the components are connected to the ESP module. For example, I connected a driver circuit, LCD display, and IR sensor, LDR sensor, a potentiometer. Everything was connected in the microcontroller, and the microcontroller has inbuilt Wi-Fi, so it will send automatically all the data to the internet. And a device which is blinking is a GSM modem. It will send SMS, and let us see how it will work. So for example, you can see now my developer is keeping a finger on LDR sensor, which detects it's a night time. So the LED will automatically turned on. So for the first condition is it will detect it's day or night. So it's based upon the light, it will automatically turned on. The second condition is if no people are there in the street, it will turn off the second light. Only one light will turn on. And third condition is if any street light is getting failure, this system is going to automatically update the status to the in charge. This street light is failed. Okay, so actually here I used 3-watt solar panel which is capable of charging 12 volt. So I used a lithium ion battery with BMS. So if you keep the solar panel, it will automatically charge the lithium ion battery. The power supply from the lithium ion battery will be utilized for the entire circuit for street lights also. Okay, so let us see the demonstration. Now you can see first the LDR sensor will detect it's a day or night. So the first array of LED will turn on, and it will check for the obstacles. How many number of people is moving towards this street light. Based upon the movement, you can see the brightness level, it is increasing. Okay, so like that the second street light also turned on if too much of obstacles are there in the street. So this is the IoT page, you can see. So obstacle detection, DR light status, battery voltage. So here now I'm going to show you the line fault status, that is battery voltage. I'm going to reduce by using the potentiometer. Okay, so now what I did is I'm going to reduce the power supply up to 8 volt like that, and I'm going to give that night condition, that is I'm going to close the LDR sensor. You can see in the IoT page it's night and there is a line fault and fault status is on. So fault status on means it will automatically send the SMS to the line in charge that the line is getting faulted. Okay, so all the parameters will be displayed in the LCD display. So now I'm turning the status to the normal. So you can see the battery voltage coming to normal position. So all the readings, that is all the parameters will be monitored by date and time, so that in future we can have an analysis or whenever the fault happen, when is the fault happen, everything we can able to track using this IoT applications. Guys, hope you understand the live demonstration. Along with this project, we will give the project report around 40 pages, which includes the abstract introduction, proposed system, advantages, existing system, disadvantages, block diagram, and hardware and software requirement, model description, literature review, circuit diagrams, hardware descriptions. So like this, around 40 pages will give the content. So 40 plus pages. So here in this document we have not included the source code and screenshot. If you added the source code and screenshot, it will come up to 60 pages. So guys, if you require this project, or if you want help to complete your final year projects or any type of projects, you can contact us, and keep subscribe our channel to get regular updates. Thanks for watching. Have a nice day.